Hello, good afternoon, and welcome to the INL Hydrogen Summit. Thank you for accepting our invitation to take part in these 2.5 days of discussion about one of the most promising alternatives to fossil fuels. Europe is leading the global awareness and action to become the first carbon neutral continent by 2050, only 30 years from now. The journey has already started. So for the opening session, we have with us today Lars Montelius, the International Iberian Nanotechnology Laboratory Director General. We have also Hélène Cray, Head of Unit for the Clean Energy Transition from the Directorate General for Research and Innovation from the European Commission, and also Manuel Heitor, Minister of Science, Technology and Higher Education of Portugal. We were counting to also have with us the Portuguese Secretary of State of Energy, João Galamba, who unfortunately is not able to join us due to unforeseen circumstances. So to welcome all of you to this INL Hydrogen Summit, the Director General of the International Iberian Nanotechnology Laboratory, Lars Montelius.
Hello, good afternoon, everyone. So my name is Lars Montelius. I'm the Director General for INL, and it's a pleasure to wish you all very welcome to the INL Summit on Hydrogen. We will run it for today and tomorrow morning. So it's an interesting event that will bring together different kind of stakeholders in order to discuss about how hydrogen can have an effect on the clean energy and the recovery plans in Europe and worldwide. So those of you that do not know INL so much, just let me say some few words about it. INL is an intergovernmental research laboratory. It was founded a little bit more than 10 years ago by the two governments of Spain and Portugal. And we're headquartered here in Braga, in Portugal. And we are right now roughly about 400 people from about 40 different countries working here. We are putting efforts in doing research in nanotechnology as a key enabling technology in different areas and different sectors. And in particular, the sectors are smart digital nanosystems, advanced materials and computation, including quantum materials and quantum computation, sustainable environment, food for future, and the precise and personalized health tech, and last but not least, of course, clean energy. So it's the clean energy that is now the focus of today's event. So the total investment for INL was about 100 million euro, and we are running a user facility. So it's a very well equipped clean room, as well as advanced microscopy and spectroscopy characterization, as well as a photonics or nanophotonics user facility that people can come and use, and of course we can give service. So one of the areas that we work heavily with is in the innovation arena, where we work together with companies worldwide. So we have representation in various places, like in Shanghai, in Hong Kong, in Austin, Texas, in Boston, in Scandinavia, in Brussels, in Israel, and we are working continuously with companies in the innovation space, besides doing the research activity, of course. With these words said, now we're going to the event of today, which is about the hydrogen economy or the hydrogen challenges. And this is, of course, related with the green recovery plans, different national energy strategies, the European Green Deal, etc. And everything is related with electrification and all the efforts about electrification in order to make a more carbon neutral economy or carbon neutral society that would have profound influence, of course, on climate, energy, and economic resilience. So with these words, I just say very welcome to all of you. I hope you will enjoy this full digital workshop for this afternoon and tomorrow. Just to give you some flair, so today we're having, besides this introduction, we're having our first session about the European hydrogen landscape, followed by a roundtable discussion related with innovation for a European hydrogen industry. And then tomorrow morning, we are starting the morning with another roundtable about opportunities, challenges for a European-based economy. And then we are ending the workshop tomorrow, the summit tomorrow, with a session about technology developments and issues and challenges and prospects, of course, related with that, and a closing ceremony. So with these words, I wish you all very welcome to INL and to a fruitful and good discussion in the summit. So thank you.
Thank you so much, Professor Lars Montelius. One of the triggers for this conference was the recent official launch of the Portuguese strategy for hydrogen. Now, from a national to an European strategy, it is our pleasure to have with us the Clean Energy Transition Head of Unit at the DG for Research and Innovation from the European Commission. So with us, Hélène Cray.
Thank you very much. I'm trying to put my camera. I hope it will come. Thank you very much for the invitation, and I am extremely honored to be here. This is a big pleasure also to be with ENL because we worked together in my previous job. And so thank you very much, Lars, and all my best wishes for the success of this event. So we are indeed at a historic moment for hydrogen and fuel cells in Europe. It's a bit a flashback for me because when I began my career in energy, we were already speaking on hydrogen and then it went down. But now it is becoming something very, very important for us to achieve our climate objective. And especially seeing now that we have increased the challenge, the level of the challenge for the EU. It is also not able to mention the positive announcement for plans for hydrogen in Portugal, and we are very, we're very impressed by the national plan, but also in other member states, France and Germany and Netherlands. And as you know, hydrogen is one of the priority of the current EU presidency by Germany. We have a high level of ambition, and we have outlined that in the package we have published early July, on the 8th of July. This package includes, and this is also to be noted, a full chapter on research and innovation. Research and innovation in hydrogen has been delivering quite a lot in the past, but it has now to deliver even more, a lot more. It has to help us decarbonizing our society through, of course, results of projects and technology, also results of social analysis studies, also supporting what we need for hydrogen economy, which is the standards, for instance, which is the support to the regulatory framework. We are in a difficult position in the EU, and especially these last days. Some people ask, why are we going to invest in that? Why people are suffering, people are dying, and you need to focus on health. We do focus on health. We do focus on medical issues, but we also have to prepare for the future. And the recovery from the current crisis, it will be long, we know it, but we have to act now. And one point I always highlight when I speak about the recovery is that the amount of money is supposed to be delivered quickly in the next 2 years or in the 2 years. However, it will impact our economy for the next 30 years because a part of it will be on investment, long-term investment. And hydrogen is exactly on that dimension. We intend to change the frame. Then, if we want to develop a hydrogen economy, what is clear from the European strategy we proposed is the enormous ramp-up of deployment which will be needed. Supported, of course, by all the other policies and especially by research and innovation. But we need a strategic approach and we need a ramp-up. We need to deploy quickly. What is behind is if we need that, it's also because we cannot rely upon only imports. One of the lessons of the current crisis is that Europe has let gone out a lot of critical steps of its value chain. I do not insist on having a fortress Europe. This is not the domain. We are working, especially in research and innovation, a lot with international cooperation. However, there are some parts of the value chains which should reintegrate, should be relocated in Europe. And this is at the core, for instance, of the proposed alliance for hydrogen. I'm sure my colleague from GROW will explain about that in the next part of this afternoon. However, this is important because currently Europe has a leadership in some technological part of the hydrogen value chain. We should not let that go out. We should benefit from all the research and innovation we have made on that. The success requires, in developing a hydrogen economy, it requires a lot of investment. It requires that our industry is convinced that this will be the future and invest in it. But on our side, it needs also that we do effort and support to improve the cost effectiveness, the reliability and the quality of the clean hydrogen generation and the applications. We should demonstrate and scale up clean hydrogen. We should accelerate the co-deployment of storage, transport and distribution infrastructure. So I'm not only speaking about research and innovation, I'm speaking about investment in infrastructure, about other EU programs and building on the synergies between this program to pave the way. It is important for industry, but it is also very important for transport because in a lot of cases, hydrogen represents the available future solution for transport. And we know that despite all the efforts in the EU, by member states and by the EU, the impact of transport on the greenhouse gas emission is not decreasing at the path we would like to see it decreasing. We have to intensify our efforts in transport. So this challenge could not be reached without a huge mobilization of private and public investment. I also have to highlight that the EU is a very small amount of the research and innovation. A lot is done by enterprises and a lot is done by member states. So we need to be sure that these investments will be targeted in the right directions and that we could help for that. And we need also to be sure that the amount of investment will be sufficient. It will go on the right place and it will have the right impact. So that's why also, excuse me, the Commission simultaneously launched the European Clean Hydrogen Alliance, which is an alliance of public authorities, industries, and civil society to facilitate coordinated investment. And just today, we have made an additional step on the call for the alliance, on the call for participating to the alliance in the various platforms. Again, Christian Weinberger could develop a little bit more that. At the beginning, we had focused on two specific sectors of the economy, the industrial applications and the mobility. And I've been speaking about the importance of transport and the importance of industry. However, hydrogen is matching a success because it is an enabler. And we have very few of such enablers, technologically speaking. So as well as electricity, hydrogen is also offering the possibility to be cross-sector and to represent a solution for some regions. And I would like to quote the experience, which is developing very well, of the hydrogen valleys, which is very flexible, but locally adjusted, way of developing at one place an hydrogen economy, a local hydrogen economy. To conclude on that, because I'm supposed to be short, I hope I was. The climate targets of the Paris Agreement, they are very challenging. And the intermediate targets of the electrolyzer capacity, 6 gigawatt for 24 and twice 40 gigawatt by 30, they are a very challenging technical objective, both in terms of industrial capacity, efficiency of the industrial processes, cost competitiveness. But if there is something I have learned in my long career now, is that when you put a very ambitious objective, people are afraid and they say, oh, you cannot match it. In reality, we can, because this helps mobilizing the energies around this objective. And very often we reach the objective. But we just need to believe that we can reach it. And especially in the case of hydrogen, where this objective is likely to produce enormous revenues and jobs, new jobs. So this event, we are participating with my colleagues of the Commission to a lot of events to try to convince. If we are convinced in the Commission, if we do believe in it, if the EU presidency, the current one, is convinced, if now the member states are adopting more and more their hydrogen strategy, it means that it will work. It needs just even more energy, if I can say it, clean energy, our brain energy, our conviction to make it happening. So thank you very much again for the invitation. Thank you very much for listening. And I wish success for this event.
Thank you so much, Hélène Cray. It will be with your participation and all of the other speakers in this first day. We will see you again in the next session as a moderator. To close this opening session representing the place where the change begins, we welcome the Portuguese Minister of Science, Technology and Higher Education, Manuel Leitor.
Thank you very much, and let me first and foremost acknowledge INL and Lars Montaldo for organizing this event. It's not the first event at INL about hydrogen, but is one very timely. Actually, I am in a different, once the meeting is virtual, I am in a different research organization in the north of Portugal, exactly discussing the challenges of using hydrogen in offshore platforms, making use of salt water. And we know this will be an enormous challenge. But let me start by addressing the way Helena Craig put these enormous challenges between investing in new green technologies and the health sector. This is a critical debate currently in Europe and worldwide, because we need to understand that we live in times of increasing uncertainty about the future, but essentially that COVID-19 and the SARS-CoV-2 has resulted particularly from animals, and it passed to human beings. And therefore, we know by scientific evidence that zoonotic diseases are increasing more and more, particularly in association with an imbalance between economic activity and the planet Earth. And therefore, in the years to come, to avoid additional and other virus like the current one, we definitely need to understand and to make sure that we implement a new balance between our economic activity that we all want to foster and the planet Earth. And therefore, this will require definitely a better compromise by articulating the health sector with the Green Deal and the opportunities for digitalization. So looking at hydrogen is exactly facing the origins of SARS-CoV-2, and therefore is so important to promote the Green Deal under which hydrogen will be a key technology, because that will be the only way we can definitely promote the sustainable development. And that is reason, as mentioned before, Portugal is so active within the European context of the future hydrogen technologies and, in general, hydrogen economy. We follow very closely the current presidency of the European Union by Germany, and we will continue during the Portuguese presidency over the first semester of 2021 this path to promote more and more, particularly also under Horizon Europe and the European Recovery Plan, the development of hydrogen. And why is that so important? I will essentially identify 5 main great challenges. The very first one is in the chemistry of hydrogen. We don't know enough. The good news is that we avoid carbon, and that will certainly decrease CO2 emissions, but we don't know yet which will be secondary effects of oxides of nitrogen coming from hydrogen use and hydrogen chemistry. So we need to know more about hydrogen chemistry. Second, and is particularly important for INL and the type of alliances INL is being promoted throughout Europe, is to look carefully at chemical processes and chemical instruments, particularly from electrolyzers to a complete different range of different ways and facilities and infrastructures to use hydrogen, among which transportation and will certainly be one of the key topics. Again, the development of cell technology in the years to come, and again, this can only be done with nanotechnology, is particularly critical for the effective use of hydrogen in a range of different equipments that we need to further develop. Again, the centrality of INL within the hydrogen strategy is very critical among many other institutions throughout Europe looking at nanotechnologies. And this is a great challenge. And my main message is to articulate among Europe and among European research organizations different ways to move further, because the challenge is so large that we need to better articulate the skills existing in different institutions, in different European regions, so that overall Europe takes a lead into this process. And instead of duplicating, we need to articulate activities, strategic, institutional strategies in each leading European institutions. The remaining 3 challenges are very critical, probably not so much associated with INL and nanotechnology, but completely critical in the future of the successful story of, or the potential successful story of hydrogen. Is about transportation. We currently in Portugal has already experienced to introduce hydrogen in our gas network about 15%, but evolving until 100% will require safe networks, and this is a great challenge for the future to come, where, for example, sensors to make sure that the transportation of hydrogen is safe will be very, very critical in years to come. My third point is about storage. Again, in Portugal, we have some experience in storing gas in mines, in salt mines, but again, throughout Europe, we need to evolve in the development of our knowledge and mining activities for storage of hydrogen. Last but not least, the 5th great challenge for the hydrogen economy will be the usage at large of hydrogen from our daily lives, in transportation, in our cities, and everywhere to provide safe utilization of hydrogen. So again, I recall the key importance of INL in a number of European networks, certainly in the Hydrogen Alliance and the hydrogen-based partnerships, but also the key role INL has been playing in the development of future cell technologies, which will be very critical for the success of hydrogen. A good day of work. Thank you very much.
Thank you so much, Minister Manuel Leitor, for your presence and for your strong incentive. INL is actively working in the research and applications for hydrogen, but also in other components of the clean energy mix. As an intergovernmental organization, INL is in a privileged position to promote cooperation in this field. For some final words about this topic, INL Director General Lars Montelius.
Thank you, George, and thank you, Manuel, and thank you, Helene, for your discussions. Very good. I mean, from INL perspective, we are ready to take the challenge in order to really move forward with the hydrogen economy, and also realizing that this is one part of electrification that goes hand in hand with the battery challenges that we also are having in front of us that we also need to address, which relates to the societal development in a sustainable way. And I think nanotechnology, as was touched upon already, is the technology that can offer many different perspectives on using our resources in the most economical way, and do it in a very careful way, of course, also realizing the different kind of possibilities that exist, also the challenges that exist in order to promote the electrification of the society. It's a necessity, I think, to have this kind of sustainable development thinking when we speak about the electrification, because everything is about carbon neutrality. It's about being much more sustainable and having a more resilient society, and also to create, of course, the prosperity, which I think is the other side that we also need to develop and take very much careful about how we can generate jobs, and in particular, how we can generate jobs in Europe, that Helene was also alluding to, which I think is very important. So we do not come in as a second tier in this aspect, but really become an important player in the not only European landscape, but also in the worldwide landscape, in order to secure the possibilities to develop the European industry in a good way. So transportation is one way of the hydrogen, of course, but it's also about the energy storage, it's about the energy transportation, it's about the utilization of renewable energies and making the kind of green transition. And I think all these things goes together with the Green Deal and the ambitious goal from the European Commission to be carbon neutral 2050, which I think everything of this plays a role together. And I think I will stop there now and then leave the word back to you, George, to end this part of the session. Thank you.
Thank you so much, Professor Lars Montelius, Hélène Cray, and Minister Manuel Leitor for your presence, at least a virtual presence, which is allowed by these pandemic times. We will now move to the first session to take a closer look at the European hydrogen landscape. I take this moment to remind you that you have the opportunity later on to go to the networking area to meet other participants that are taking part in this hydrogen summit. We are very pleased to promote your interaction and your cooperation of interests. So during the coffee break, you will have that opportunity. You will have also the opportunity to know INL better in the exhibition area. So we have now our panel of speakers for the first session. So Christian Weinberger, Senior Advisor of the Advanced Industrial Technologies, hydrogen coordinator at the European Commission from the Directorate General of GROW. Petros Sofronis, Director of the International Institute for Carbon Neutral Energy Research. Luigi Crema, Hydrogen Europe Research Board member. Thomas Kabaga, Executive Board Chairman of the Renewable Energy Institute, and Stephen McPhail, coordinator of the joint program on fuel cells and hydrogen era. So we invite you to take part in the Q&A period in the end of this panel. We will have a short presentation by each one of the speakers, and by short, we mean 5 minutes. Then the debate will be moderated by the Clean Energy Transition Head of Unit at the DG for Research and Innovation, Hélène Cray. So now we welcome Christian Weinberger.
Hello, good afternoon. Can you hear me?
We can hear you perfectly.
Okay, thanks very much. Good afternoon. Thanks for the invitation. I think it's very timely at this point in time to talk about hydrogen and its role in the future of the EU industrial landscape, in particular in the context of the Green Deal. Let me point out that, in fact, hydrogen, some people think it's a hype, but de facto it's not a hype, but it's a very important tool, one of the tools, in order to achieve the Green Deal goals. And this is because of the role that hydrogen can play in a new context. People mention hydrogen is very fossil today. This is true, because today's production of hydrogen as a feedstock for chemical industry and refineries is very much linked to natural gas and very much linked to CO2 emissions. But that is one small element of it. There is indeed a potential to reduce the CO2 emissions of that hydrogen produced, but that's certainly not the full picture. The full picture includes the role of hydrogen as a carrier of renewable energy for many different purposes in industry, including, of course, mobility sector, like heavy-duty vehicles, where it will play a role very important in decarbonizing the heavy-duty traffic and transport, and other transport areas. I don't want to exclude anything. Ships and airplanes, all of this is very important for decarbonization, but it also has a role in the industrial production of steel, for example, but also cement, and also generally the industrial heat is something that today very much relies on natural gas, and that role should be replaced by hydrogen at some point, or there's a potential to replace it by hydrogen at some point in time. So the new role of hydrogen is not so much linked to a chemical substance, but it is linked very much to transport renewable energy from the place where it is best produced to the place where it is best, where it's needed, where it's most needed. And by best produce, what I'm referring to is that that you have quite different conditions in different member states of the EU for the production of renewable electricity. And the places where is the best production conditions, like Portugal or Spain, or even if you go a bit further in the north of Africa, are far away from the locations where it's needed. And for that, hydrogen is an ideal tool, in particular when what you can actually use afterwards is hydrogen in the production process. Because of all this, the Commission has decided to come up with its own strategy, hydrogen strategy, because of this recognition that it is very important. And also, this is something that we will have to develop more specifically in its own context. And what in essence the hydrogen strategy says is that what is needed most is to bring together and to synchronously get up the demand and the supply. Because if you have a lot of supply and nobody uses it, this is commercially completely unviable, and vice versa. And at the same time, during this period of increasing the production and also the increasing the usage side, there will also be a need for public subsidies, because this cannot be standing on its own feet. But that's, of course, wherever you talk about the real Green Deal, there is a need to invest public money to achieve the objectives. So this linking up supply and demand is a very important element, if not the key element, of the hydrogen strategy of the EU. Another important element is the objectives that are put forward. It is something that should happen on short term. We don't wait for 2050, because by then you need to have a lot of things already scaled up. But we want by 2024 already have achieved the production of 1 million tons of green hydrogen, renewable hydrogen, in this rather short period of time, because there's a lot of investments needed, a lot of decisions needed. So that's ambitious, but it's doable. And at the same time, there's a 2030 goal that is set forth by the EU hydrogen strategy of 10 million tons of renewable hydrogen. Again, ambitious, but doable. And in particular, of course, also in the light of now the projects that are appearing everywhere. And one concrete process to trigger the further evolution of these projects that will implement these objectives is the European Clean Hydrogen Alliance, which has the objective of creating a project pipeline, of identifying who should do what, who is willing to do what, and what are the financial resources needed by industry, but together with the member states, and try to find the financial means to cover the gap between what is needed and what is financially viable. There's a big interest to do this. There's also recovery funds that will be available for this. And if you are interested, you can also join the European Clean Hydrogen Alliance on its website. Just Google it and you'll find it immediately, and sign the declaration, and you become member of the effort. There's going to be roundtables to discuss the things. There's going to be the EU Hydrogen Forum on 26 and 27 November this year, and there's going to be further fora, more or less every half year, where things will be discussed, and where also the conclusions will be made how to move forward. I think I'll leave it at that for the moment, but this should set a bit the background of the real ambition of the European Commission to get things moving in this context. Thank you.
Thank you so much, Christian Weinberger. I remind all of our attendees that you can put your questions using the chat in the platform, so you're very welcome to do so. And now we are also welcoming Petros Sofronis to the discussion. Petros, you need to unmute before speaking. Thank you.
Am I okay?
Perfect.
Can you hear
Welcome.
me? Yes. Thank you. Thank you for the invitation to speak at this INL forum on hydrogen and the future of the world, I would say, because hydrogen is the future of the world. Let me introduce myself. My name is Petros Sofronis. I'm a professor at the Department of Mechanical Science and Engineering at the University of Illinois at Urbana-Champaign. At the same time, I'm also a professor at Kyushu University in Japan, one of the 7 imperial universities of Japan. And I'm the director of this institute, International Institute for Carbon Neutral Energy Research, which is a joint institute between the 2 universities, University of Illinois at Urbana-Champaign and Kyushu University. The objective of our institute that I'm directing is to develop the fundamental science that will allow the development, the technological development of low carbon, low cost, and high efficiency energy systems. At the same time, we aim at bringing the international community together in the US and in Japan, and of course from Europe, so that we can all together utilize the available talent that we have in order to advance carbon neutral energy technologies. As Dr. Weinberger said today, key key way to advance carbon neutrality in the world is hydrogen, and hydrogen is a very important aspect of our institute. We are working on several aspects that will enable the technology development. One is on issues of catalysis. As you know, in order to develop, in order to produce hydrogen, in order to create hydrogen, you need to use, for instance, electrolysis. The electrolyzers involve electrodes, and those electrodes have various surface exchange kinetics, where we try, for instance, to incorporate oxygen into the system, incorporate hydrogen into the system, and so on and so forth. And there are some fundamental science issues there that we try to understand and also optimize. Another area that we are working on is the so-called reversible fuel cells. The reversible fuel cells, as you know, you can, if you have excess electricity because of wind or solar, then you can use this excess electricity to create hydrogen by electrolysis, store hydrogen, and then feed that hydrogen through a reversible fuel cell into the grid. So one of the best solutions for the grid scale energy storage is hydrogen. I cannot imagine any other better solution. At the same time, we are also working in the area of materials for hydrogen infrastructure. We've heard, for instance, that the transportation of hydrogen is a very important issue. Transporting hydrogen in the pipelines, adding hydrogen in the mix. For instance, we can put 5%, 10%, 15% hydrogen in the natural gas mix. That requires some understanding how hydrogen reacts with the materials. Let me tell you today that no steel has been developed by having hydrogen in mind. So we need the next generation of steels that will be able to accommodate hydrogen, the next generation of materials, the next generation of fiber composites, so that we can safely and reliably transport hydrogen. This is another issue where fundamental science is being advanced in this institute. At the same time, we are carrying out some fundamental research in the area of small molecule science. This is a fascinating area that I believe in the future will involve the next Nobel Prize in chemistry. Breaking small molecules in an efficient way is the future of energy. Breaking CO2, for instance, as you know, CO2 is a very stable compound. Breaking CO2 is essentially a way to decarbonize the future. Breaking or forming ammonia in order to produce hydrogen is another important issue. For instance, as you know, ammonia is, with the technologies that we have to produce ammonia today are almost a century old. So we need a new innovation, a new scientific breakthrough. Breaking hydrogen efficiently is again involving catalysis. This is another wonderful area where the scientific community can get together and impact change. So this small molecule science is something that we in the academic community are aiming to bring about change. So at the same time, in this institute, we try to advance international collaborations. With Europe, we are working with a great number of institutes. One of the institutes we are working is the Imperial College London in the area of catalysis for fuel cells. We are working with the University of Göttingen in Germany in the area of materials for hydrogen, and so on and so forth. At the same time, we are working here at the University of Illinois with the Argonne National Laboratory, which has a very large program on hydrogen and fuel cell technologies. And we have just created the so-called Midwestern Hydrogen Partnership. Again, there is no time more opportune to have such a partnership created. I look forward that we collaborate with INL because, as Dr. Weinberger said, hydrogen can be applied in many sectors of the society, like producing steel, producing ammonia, in all chemical industry, and so on and so forth. And this partnership here in Midwest, working with the United States Department of Energy, is aiming at advancing this area, the chemical and industrial uses of hydrogen, not only in transportation, in other words, because the future of jobs, the new jobs, the creation of new jobs relies heavily in hydrogen. For instance, I can give you an example. As you know, Caterpillar here is a big US industry, right, that works with and develops and manufactures heavy duty equipment. Caterpillar is interested in decarbonizing the environment. Decarbonizing the environment means we need to switch and work with fuel cells. Hydrogen in heavy duty equipments. That's the future of this heavy duty industry. Maritime, having ships, having in harbors those small boats that carry equipment and load the big ships. Here again, hydrogen is the area where we can find efficient ways to achieve our goals. So without further ado, I think I spoke for the time that has been allotted to me. I'd like to thank you, and I'd like to send a very optimistic message. Hydrogen is the future of our societies. Hydrogen is the future of Asia, of Europe, of the United States, and institutes like ours work to bring the international community together so that we can take advantage of the talent that we have in all of our countries. Thank you very much, and I look forward to the discussion.
Thank you so much, Petros Sofronis, for your contribution. And now, Luigi Crema, thank you also for being here with us today. Welcome.
Thanks for your kind invitation, and I'm really happy to be part of the ENL Forum on Hydrogen. Good afternoon to all the participants and attendees. I'm here representing Hydrogen Europe Research. I'm board member in the Research Association and chairing the technical committee on hydrogen production. Hydrogen Europe Research is a research organization part of the European Partnership on Hydrogen, which is known as a Fuel Cell and Hydrogen Joint Undertaking in Horizon 2020, and now actually renamed as a Clean Hydrogen for Europe in the next framework program. This is a public-private partnership participated by the European Commission and industry and research groupings. We see there is a momentum on hydrogen at the European, let's say, global scales. And we see even that in this respect, Europe is well prepared in the international context. I'm quoting so much the recent awards given by Sofronis on the international collaboration, which I support so much. Europe is well prepared in this international context with several sectors of leadership within the hydrogen world chain, from production to logistics and transport to end uses. Why is this possible today? This is, I think, an important lesson, not only reserved to Europe, but even in the global context. There has been a continuous support in the European framework programs since almost 35 years to the hydrogen sector, with the support even to scaling up of initiative in a well-coordinated program. Actually, there are indeed a lot of open challenges, among which I would like to mention the need to accelerate the commercial maturity of hydrogen across all the sectors of transport, heating and power, in the residential use and industry. We have the need to enable at scale deployment capacity, the need to ensure a safe deployment of clean hydrogen in the respect of the societal challenges. Hydrogen Europe Research, with its 82 members, among which we account universities, research centers from 19 member states and 5 associated countries, is keen to give a dedicated support and to guarantee the European leadership and international collaboration in the respect of hydrogen. We are convinced that research can have and must have a major role to play, supporting the RD&I cycle from the very low to the high technology maturity levels. And Hydrogen Europe research at the European level is ready to support the European strategy and the development of the hydrogen economy with a wide range of competencies, skills, infrastructures that are available through our members. We are keen to support from basic research to material science, to modeling, to the design of novel technologies such as novel cells, novel hydrogen production systems, to support advanced engineering, digitalization, and many others. We have some targets in this dedicated support, which are the first is to intensify the research and industry collaborations. In several years, we have built, together with the industry, a whole ecosystem in a common understanding and trust. This is happening inside the European Partnership on Hydrogen. We have aligned the R&D and I efforts with the industrial needs. We have received through a pool approach the industry guidance, complemented by challenges defined by research, co-construction with the common objective to reach impact, no overlaps or gaps in between, synergies with other sectors with the care not to break the existing EU ecosystem on hydrogen and to play even complementary roles among the several European partnership. As a second target, to contribute to keep the European industry at the forefront of the innovation. So preparing the next generation of products, even addressing critical technical barriers, monitoring the evolution of the key performance indicators year by year. We are keen even to work on the challenge of the education and training. We need to educate and train engineers, technicians, and operators to ensure high qualified jobs. And this is much required from the overall sector. Few words on Hydrogen Europe research before closing. The association is structured with the General Assembly represented by all the members, a governing board with elected members in the roles of president, vice president, with 8 technical committee leaders and chairs, and several roadmap leaders supporting the different activities. We have staff people on a secretariat and innovation management, and we are providing all our benefits in innovation, policy, knowledge, profile, and network to the members. To Hydrogen Europe research can join public research organizations or universities and non-profit organizations. So to conclude, we are part of the European hydrogen ecosystem, but with the look to the international collaboration. All our effort will be required to support the next challenges of the hydrogen sector, and Hydrogen Europe research is ready to play its role on this. Many thanks for your attention.
We thank you very much, Luigi Crema. And now we welcome Thomas Kabaga.
Thank you. And I was introduced as Executive Board Chairman of Renewable Energy Institute, which is Tokyo-based and has given me, as Professor Sofronius, a bit of contact with the Japanese development. But in Europe, I'm mainly working for the EIT InnoEnergy on industrial development in the energy field. And I'm also on the Swedish Committee for a National Hydrogen Strategy in Sweden. In summary, I would say that the reason why hydrogen has become relevant today is that renewable electricity generation technologies have, thanks to industrial learning, become so cheap that solar and wind energy now in many parts of the world are not only cheaper than other sources of electricity, but also cheaper per unit energy than oil and sometimes gas. And that makes it economically feasible to produce fuels from electricity. Traditionally, it's been the other way around. However, in order to be economically successful, we need to get down the cost of electrolyzers, and if you want to go the other way, also fuel cells. And this indeed is something that will require quite a bit of research and development. But most of all, again, it's industrial experience and scale up that will contribute to a real world cost decrease. So the industrialization of these technologies on a large scale is very important for competitiveness in a geopolitical sense. And I think what we now see in Europe is very much a concerted effort to be successful in Europe in this process. The technologies to handle hydrogen has been mentioned, where material science and chemical engineering is going to be very important. And I would expect that the first competitive applications of hydrogen from electricity will be in industry, because when you are able to produce large-scale hydrogen and use it where the hydrogen is produced, avoiding the cost of transportation in the initial stages of this development, that will be the most competitive area where early introduction will be most feasible. So steel manufacturing, some chemical industry, fuel production, liquid fuel production using hydrogen instead of fossil hydrogen, as renewable electrohydrogen instead of fossil hydrogen, may be early applications. And the potential is so enormous that selecting a few early applications that can help drive the industrial development of electrolyzers and other supporting technologies will be extremely important for the long-term success. Thank you.
Thank you so much, Thomas Kaberger. Now the last short presentation before the debate with Stephen McPhail.
Thank you very much for your introduction, and thanks to INL for inviting me to this illustrious panel of experts on the hydrogen panorama worldwide. I am the joint program coordinator of the Fuel Cells and Hydrogen Joint Program, which is one of the joint programs in the European Energy Research Alliance. So a couple of words on the European Energy Research Alliance, which is an association of over 250 organizations, universities, and RTOs working on research in energy in the vast panorama of what is energy. It likes to be an advisor to the European Commission in terms of the priorities and pathways and strategies for energy research, so research aspects in the field of energy, especially looking at the decarbonization, long-term decarbonization of the European Union. So it is the biggest association of research organizations working on energy in Europe, and it is structured in 17 so-called joint programs, which represent not only the different energy technologies such as wind power, solar energy, ocean energy, geothermal, and all the primary energy sources, but also technologies like carbon capture and storage, and of course fuel cells and hydrogen, but also bioenergy and cross-cutting aspects like advanced materials, and also importantly the social and humanities aspect of energy solutions and energy system integration. So this is a context which very adequately, I think, reflects what is the paradigm of the energy transition, namely that it is a intensely cross-cutting and all-embracing initiative, which needs to take into consideration not only the technological achievements of single technology silos and technological disciplines, but needs to branch out to the impacts in terms of the end users, in terms of infrastructural consequences for the member states and for the member states unified in a common economic area. The joint program Fuel Cells and Hydrogen in this respect is one of the key links that actually connects up to all these different aspects, thanks to the phenomenal diversity and in applications and in generation that hydrogen has as a property. So our main interest is to explore through the in-depth knowledge of the key scientific mechanisms and principles and theories and knowledge that lie at the basis of hydrogen technologies, to see where are the interfaces with technological challenges also in other fields. I'm thinking of the CO2 separation and storage issues. I'm thinking of material issues that you also encounter in nuclear reactors. I'm thinking of interfaces with bioenergy and with energy storage, chemical storage versus electrochemical storage. So being a grouping that is fundamentally unhindered by budget restrictions, so we are actually an association of scientists that come together purely to speak about the scientific implications of how the hydrogen evolution will touch the actual technologies. So better catalysts for electrolyzers, cheaper processes for storage, transport, and generation. We also therefore can investigate what will be the long-term strategies in terms of how to realize either large volume of hydrogen. So do we want to go to short-term rapid increase of the volume of hydrogen that is produced and consumed, or do we want to bank on a little bit more time and maintain the value of hydrogen as high as possible, and therefore foster a pure hydrogen economy rather than looking for blending solutions? We can all assess all these things very freely and discourse with our colleagues in the other scientific disciplines to see how the scientific challenges that come from this can be resolved through a cross-cutting collaboration, and also how they impact other sectors of the energy transition in terms of large-scale integration of energy production and consumption, and the impacts in terms of the built environment. So that is more or less our role. We've done some prepared some important outputs also together with Hydrogen Europe Research, especially Luigi Crema knows very well that we've been working a lot on a common document on formulating key performance indicators for research, key research items in the fuel cells and hydrogen technology area, as well as preparing supporting documents either for ERA or for the scientific community that we represent. If you're interested in knowing more about us, go to the European Energy Research Alliance and you'll find our dedicated website there. Thank you very much.
Thank you so much, Stephen McPhail, and thank you to all the speakers who will now take part in the debate moderated by Hélène Cray. We already have some questions from our audience. The first question from João Carvalho. Good day. When is expected to have cars and stations with hydrogen supply in the EU? Another question from Jorge Aponte. Please explain more about breaking CO2 molecules and the challenges involved. We also have Teja Vin, another question. Which type of hydrogen production technology will play a major role in the future? For example, what about photoelectrochemical systems? How long would they take to reach the commercial stage, and what are the major challenges? We also have another question from Sasha Sadewasser. Is there a EU roadmap for the transition from gray and blue hydrogen to green hydrogen? What is the main time frame for this transition? And how do you foresee the development of the hydrogen production and storage facilities, centralized or decentralized? So we have also another question from Maurice Dawaliben. Which renewable energy technology do you think is more efficient when it comes to the transportation sector, electric cars or hydrogen fuel cells, and why? So we can see many questions here, which highlights the interest that is generated by hydrogen. So Helen, it's up to you now to conduct the debate. I believe that we have several good topics for it right now. Thank you.
Thank you very much. So if I understand well, there are questions on the EU, there are questions on the type of production, the type of supply methods we can have. That will be great. Maybe if you can put on the chat accessible to one the detailed list of questions, because I have to say that my memory sometimes cannot find everything at the same moment. I would like maybe to become in a rational way and look on the question on the types of hydrogen production, and maybe asking Mr. Crema to look at it, won't you?
Oh, many thanks. Yes, on hydrogen production, of course, there are several technologies that are in the way to have a role in this field. The European program is structured into two main roadmaps. One is related to electrolysis, which is much supported by the European strategy on hydrogen. And electrolysis is a set of technologies from the most developed and advanced, ready for market scaling up. For example, in alkaline electrolysis and PEM electrolysis, to one technologies which is almost going to be ready for market uptake, which is related to the high temperature solid oxide electrolysis, and two emerging but promising solutions that will be supported even in the research sector in Europe, which are the anionic exchange membrane electrolyzers and the proton conductive ceramic electrolyzers, which could have even additional functions other than producing only hydrogen. Going to the point of other ways to produce, yes, there could be a role on hydrogen direct production from solar energy, and this is included in the roadmap 2 of the European program, where there are three main solutions that will be supported. One is related to the thermocatalysis, so the high temperature hydrogen direct production from sun, which is probably the most ready to mature in the next years, reaching 10% of overall efficiency, but with the requirement to bypass this threshold and go into around 15-20% of overall efficiency, which is seen as a feasible target. And then the photocatalysis and photoelectrochemical catalysis are two other ways to produce hydrogen by sun. Photocatalysis is, let's say, probably in between the less mature technologies and solutions in between the three today, and will be supported from low TRL at the European scale. We have a challenge on catalysts here, on duration of the technology, on having higher efficiencies to move step by step the solution to a higher maturity first, and then to consolidate economical feasibility and scaling up. I think we need here the whole next program to mature in 7 years this technology to go then towards an innovation loop and then a scaling up.
I'm always happy when someone is trying to give me more work in supporting the new technologies for production. That's very interesting. I would like maybe to ask first Professor Sophronis, and then Christian would like to complete maybe. But as we have a lot of questions, I would like maybe to ask the further speakers to be a little bit shorter so we can take almost all the questions. Thank you. Professor Sophronis and then Christian.
I can comment as well.
Am I okay? Can you hear me?
Yes, we do. Please go on.
Okay. Absolutely, I agree with Luigi Crema here about the ways to produce hydrogen. All those are potential ways. There is a future in this direction. I would also like to add another one, which is the biomimetic catalysis. In nature, there are a lot of enzymes, bacteria that can produce hydrogen, and in the laboratories, what we can do, we can somewhat unlock the mechanism by which these bacteria produce hydrogen and then create synthetic analogs. In fact, we are doing this exactly. For instance, we are doing this in Japan. It is happening in Europe in laboratories by creating these synthetic analogs. But again, some of the problems that we face here are the stability of the catalyst and the efficiency. But this is again the next breakthrough that we are expecting for technological implementation. So I think that there was another question, if you wish me to take it, about the breaking of small molecules. This is, again, for instance, breaking CO2 is a very difficult subject, extremely very difficult chemical reactions. Is stable. CO2 is as stable as the water, for instance, right? I mean, water is ubiquitous in nature. And what happens with CO2, we can break it, but the products that we will create by breaking CO2, for instance, if we can break CO2 in order to create gasoline, for instance, right, so that we keep carbon neutrality. The gasoline that we create now, our techno-economic analysis in our institute shows that its price is about $12 per gallon. Here in the US, the price is $2 to $3 per gallon. So again, cost is a very important aspect when we deal with renewable hydrogen. So we need to carry out again the breakthrough in order to reduce the cost of production. So then I leave it there.
Yes, Christian, please now.
Yes, thank you very much. I think I can take it up at the last remark of the professor. The cost is the important thing. And the question is not so much which is the technology. The question is who will be the one producing large quantities of hydrogen first? Where? Which part of the world? And if we spend another 7 years researching, I can tell you who it will be. It will be the Chinese. We need to start today. This is why we have this hydrogen strategy at the EU. We need to start today to produce in large quantities, because the answer, there was another question on when will blue hydrogen be replaced by green hydrogen. The answer is not in terms of years, the answer is in terms of gigawatts. Bloomberg NEF has predicted that as soon as 25 gigawatt of hydrogen production facilities are established worldwide, this will be the break even. So if this takes until 2050, then it will be 2050 when it will be cheaper. If this is done by 2028, then 2028 is the year when green hydrogen will be cheaper than blue. So we need to get going with production facilities. We need to get the prices down by starting immediately for the electrolyzers. This was also mentioned, and this is the way forward to also achieve to reduce the number of euros needed in order to get the hydrogen production facility economically viable. It will require euros from taxpayers, but the faster we move, the less will be the money needed from the taxpayers, because we get into the from the red zone into the black zone on the cost for the production. So let's not think about what's the methodology. We have the methodology now. We can still optimize. Maybe in 7 years we'll have a new methodology, and further capacities will use a new methodology. But let's not keep us from starting with rollout of technology now in Europe.
Well, thank you very much, Christian. I would like to maybe complete a little bit on that. Indeed, that I fully agree with you. And although the strategy on hydrogen is presenting a step-by-step approach for the EU, it's clear that we will go for green hydrogen, and it's clear that the supply and the demand should go hand in hand. We can not continue to have, I mean, we cannot foresee to develop a hydrogen economy based on imports from outside, which is also raising issues on the overall carbon record of such imports. I would like to go now to continue maybe on that line, a little bit deviating. I see that there is a question on a comparison between electricity and hydrogen in cars, electric cars or hydrogen fuel cell. It looks like a renewable energy supply, but I would like to extend a little bit this question and ask Mr. Kaberger to intervene on the type of supply we can use for hydrogen, not the technology, but the type of supply and how he sees the situation for EU. Because if we need a lot of hydrogen, we will need a lot of green electricity, and we will need a lot of renewable energy. Mr. Kaberger, would you like to intervene on that?
Yes, thank you. Indeed, we will need a lot of renewable electricity in order to be able to not only displace fossil-based electricity generation, but also produce fuels via hydrogen. And I think this has become very possible because of the low cost of renewable electricity, now possible also in Europe. We saw the last auctions and prices for solar electricity on the Iberian Peninsula, for example, as very encouraging examples. And I do believe that if we look at cars, which there was a question on here, battery electric vehicles will be very competitive to fuel cell vehicles, because battery electric vehicles are simpler, and battery technology development and industrial development has come earlier, and they seem to be very competitive now. And the increase in the use of battery electric cars is mainly limited by availability of battery cells today. So this will go on, but there are many other opportunities for hydrogen. And there was one question on centralized versus decentralized. Well, as I hinted in my introduction, I think we will see centralized production of hydrogen for industrial purposes as early movers in this development. But that they are large scale does not mean that the electrolyzers necessarily are individually large scale, because electrolyzers can be produced in a modular fashion, so that you have a large number of small electrolyzers as a way of decreasing cost. And when you get costs down, then they will also be economically feasible in decentralized applications, even at household level. So there is a matter of finding a suitable industrialization strategy that will help bring down cost in an efficient way. One additional idea that I think is worth mentioning is that when you look at what kind of electrolyzers that will be the most winning, profitable, efficient electrolyzers, some people believe that there is one technology that will win in a competition. I believe that we will see a range of different electrolyzers used in different applications, because there will be some electrolyzers that will be used opportunistically in an electricity market where prices are varying. If you want to operate an electrolyzer throughout the year, throughout the day, 8,000 hours per year, then you can pay a lot for high efficiency. But there will also be a room for opportunistic electrolyzers that may be very cheap, have low efficiency, and operate only when electricity costs are very low. If you have negative electricity prices, efficiency is not important. So there will be a range of technologies that will be able to make profit on the market. Thank you.
Thank you very much. I will use this type of approach, which means a flexibility of the supply technologies and utilization, and to also link it to the flexibility in the utilization itself, in the side of demand. There should be flexibility in the two sides, and this is exactly the role of an enabler, by the way. And I would like to take on board a question which looks very simple, but is not that simple, which is the deal between electric cars and hydrogens, and how many, and hydrogen cars, and how many, when do we expect to see stations where you can refuel with hydrogen, which is already existing, by the way. It's not new. It does exist. The problem is the magnitude. It's not the station itself. And the problem is the legal framework around, which is also an issue. When I saw also, when I heard Mr. MacPhail speaking also on fostering a pure hydrogen economy or a blending solution, would you like to refine a little bit more? And I will make you a very, let's say, provocative challenge. Mr. MacPhail, maybe Mr. Kaberger, you could stop your video so that we can see Mr. MacPhail, if he can enter.
I'm here.
So yes, so a kind of provocative. Well, don't you think that a blending, beginning with some type of hydrogen, is a way to attract the demand to use more hydrogen, and then will provoke the supply? Or would you see the reverse way, that we need to feed a lot of hydrogen, green hydrogen, to provoke the demand?
That is indeed a tricky question, and as was already mentioned by one of my colleague panelists, it needs to go hand in hand. Clearly, from a pure and simple mass balance point of view, the generation of hydrogen needs to match what is used. So any kind of strategy needs to make sure that these things go hand in hand, which is also the way to break out of the chicken and egg circle that we know characterizes the issue of whether we should have hydrogen refueling stations first or hydrogen cars first. These need to be obviously be fed into the system simultaneously, using appropriate planning and intelligent flagship projects that attract attention, that show best case or best practice, and that demonstrate the feasibility in specific conditions that can be replicated, and thereby multiply both the generation and the utilization. The issue of whether to the dilemma of whether to go for volume or for value is clearly one that is also closely connected to the decision of promoting blue hydrogen versus green hydrogen. In the short term, it is clear that reforming of natural gas is a supremely mature technology that is also unbeatably cheap, even considering all the developments in electricity prices and gas prices. And therefore, the option of trying to sequester CO2 generated from this process and use hydrogen in large volumes and at low costs, which is also a clear condition for which an infrastructure can take place, because the end users want to make sure that the hydrogen will be available at costs that allow a payback of the infrastructure that they need to invest in. However, it is clear that that is leads into all sorts of other issues as well. What do I do with the CO2? Is there an economy of CO2 which needs to be brought up at the same time? The other issue is blending it with natural gas can lead to an immediate increase of the volume also in the offtake. I mean, only looking at the utilization of natural gas in residential and industrial boilers clearly would, if this could be used, that would create an enormous demand for hydrogen, and therefore that is an important solution to look into. But how do we foster the value of hydrogen in its pure form, which relates to the flexibility that it can allow in terms of sector coupling, but also in terms of rethinking industrial processes and creating the economic returns that hydrogen as a valuable commodity can generate. So a hydrogen refueling station will have a given price of hydrogen, whereas hydrogen mixed with natural gas will be driven by the price of natural gas, which is much lower. So it is clearly something that, as usual, needs to be done on all fronts. So we need to investigate we need to mature, short the low-hanging fruit and gain immediate results in order to gain confidence with the vector to create the habit with industries that are maybe not inherently connected to hydrogen to prepare and to engineer for hydrogen-based solutions. But the question is if that will lead to a sustainable conversion of the of infrastructures towards a system that is oriented towards 2050, or will we at some point in any case have to do a quantum leap in terms of the infrastructure, for example, putting down a pure hydrogen grid instead of a natural gas grid. So these things need to be thought out. It's important to get quick results at scale in order to change the frame of mind of also the general public and policymakers. But it needs to lead to a clear pathway where a structural solution is thought out in the medium term.
Thank you very much. Time is running, so we should limit ourselves a little bit more in our answers. Thank you very much. That was very interesting. I would like just to make a point myself on a question. When hydrogen to be used in the heating sector, or will it be limited to specific industry and long-haul transport, or maritime also? We don't see or in that sentence, at least at the EU. We are developing both. We are developing enabling role of hydrogen for decarbonizing hard-to-abate sectors, like indeed some specific industries or some part of transport. But we are also supporting very much, and I think that Mr. Krema could say it because it's supported also by the partnership with industry. We're also supporting very much, including at international level, the notion of hydrogen valleys, which is to have a multi-use of hydrogen, multi-sectors, including residential, on a specific place, which could be a city or a region or an island, where it is matching the needs. Just think on the Orkneys Island, or on a big city like the south of France in Pau, or in, I think it's Groningen in the Netherlands. I don't remember exactly. I think it's Groningen, reusing the gas network. So just to make this point. Now, I would like that we have been very technical. Let's go to economics, and Mr. McPhail opened that debate, by the way. Do we need to consider and add environmental and social costs to the final price value? Just to mention that the European Commission in its Green Deal and now its recovery program is proposing quite a lot of things and anticipating. Christian, would you like to take the floor on that? Because I'm not supposed to speak, I'm supposed to animate. Christian?
Yes, I'm here. Can you hear me? Yeah, okay. I think it is very important. You asked the specific question about the social cost, and it is a reason for different sectors being at different competitiveness level. Because we heard this before already, there's a different price that you will get when you feed hydrogen into the gas network to hydrogen that you feed into an industrial application, to hydrogen that you feed in the transport sector in refueling stations. Because in refueling stations, you're competing with diesel, and diesel has included in its price, depending on which member state we talk about, a 200 price tax, the mineral oil tax, that increases the diesel price in order to take into account the social cost of fossil fuels. So there, if you want to be competitive, you can actually offer a price of €5 per kilogram of hydrogen, and that will be competitive with diesel if you get the price of the equipment down, so the drivetrain of trucks in particular. Whereas if you feed it into a gas pipeline as a blend, you will probably not be able to achieve €1 per kilogram. So there would be a need to help through public money, public funding, to subsidize the price. If you talk about putting hydrogen in the gas network, the difference being very much that you have 100 refueling stations. That was also another question. Today, already in Germany for hydrogen, 190 throughout Europe, but these 100 refueling stations in Germany are serving 500 cars. So it's not a competitive way of arranging things. There's a need to increase the cars. And I think, to be honest, let's not discuss so much about passenger cars. This is something where we will see where things will go. Let's talk about heavy duty. And in heavy duty, it's very clear that batteries are not suitable for long distance. As one executive of the truck manufacturers put it, we are in the business of transporting goods and not of transporting batteries, sorry. Because you need a third of the tonnage of the truck in batteries in order to go 700 kilometers. So there is the market for hydrogen, and there will be the market for refueling stations finally to be commercially viable. And there will be also an important point, but it's the will be. So the demand there is very little. On the other hand, the demand in pipelines being blended is endless. You know, you can go. It's proven. There's actually no question about it. You can go up to 5% mixing of hydrogen into the gas grid, and that will not harm any of the applications. These 5% represent the goals that we have until 2050. So we can produce endless numbers of green hydrogen just to feed it into the gas grid. There's technically no issue, but there's the commercial issue there, because the €1 or 90 cents per kilogram is commercially not achievable. So there is a need to act from a public policy perspective. And there you could have sort of like a prescription, like it happened with organic substances in diesel, blending diesel. But if it would be prescribed by public sources, it would increase the price of gas very little, but it could help to kick off the market in big volume for hydrogen production. Helen, I think maybe I have one more point to refer to. There's also ideas in the Innovation Fund, in the ETS Innovation Fund. There is concretely measures in the Recovery Fund where the Commission very much wants to favor the application of these funding methods for new methods of alternative production of energy and electricity. And there clearly hydrogen is one of the main topics. And we hope, even though it will take a bit of time for these funds to get unblocked, not the ETS. The ETS is actually closing, I think, today or tomorrow, the application for the first round of the ETS. But certainly the recovery funds, which will be enormous amounts of money, are still under negotiation, but they could certainly be used for large-scale projects that will get the price down to a level where many things become more competitive. And maybe a last point is the aviation fuels, because there we can see also the effect that it has, that the aviation fuels don't have any mineral oil tax. So there's no compensation tax for the environmental damages that kerosene does. It's maybe not the right time now to put additional costs to the airlines because they're already suffering big problems. But there, if you would have this compensation, as it has been put forward by one of the questions, of the damage to the environment be put into a tax on the fuel itself, there you could immediately get e-fuels, e-kerosene, which is again produced from green hydrogen in the first place, get that more competitive. So there is a need for public policy measures in order to get hydrogen viable on many different fronts and blending different initiatives. But the offerings by the European Commission are available. We need projects now to take them up.
Can I add a point?
Thank you very much. Thank you very much. We have something like less than 10 minutes left. So I will ask each of you, if you want to complete, to limit yourself to 1 minute, please. And we would like to hear indeed the remaining panelists on this social and this external cost issue and the costing. 1 minute. I will be tough. You are warned. Thank you. Go on, please.
I'd like to mention that the hydrogen production can take place through nuclear energy also. Here, for instance, a good example is here in the US. As you know, Illinois, the state of Illinois is the Sweden of Europe. It is the state that has the most nuclear reactors because nuclear reactors were first deployed here in the state of Illinois. As you know, because of the renewable energy has become so cheap, right? Solar energy, wind energy, the nuclear reactors, the nuclear power industry experiences a cost problem. And so the nuclear power industry right now is thinking of repurposing nuclear reactors just for the specific reason of producing hydrogen when the demand is not high, for instance, during nights and so on and so forth. So there is a way also to keep the nuclear industry working for the hydrogen economy in the future to produce cheap hydrogen. Another way also that we should think about the social issue, perhaps more of economics. As you know, the oil and gas industry right now is facing tremendous pressure, I believe, from the stakeholders and the investors that they have to decarbonize and they have to move into the new game of renewable future for the entire world. I was at a meeting the other day, at a BP meeting, in which BP wants to be carbon neutral by 2050. I believe this is a tremendous breaking news. I mean, a major oil industry to want to participate in this area and has invested in many hydrogen production projects. In fact, right now there are 8 hydrogen production projects in coordination amongst the Imperial College, University of Illinois, and University of Manchester in England, how to produce hydrogen cheaply. So, and at the same time, I believe also this oil and gas industry can help the transition to the hydrogen economy through the production of blue hydrogen. In other words, we can somewhat have a balanced economic perspective here by using even the oil and gas industry in order to produce, in order to activate and mobilize the hydrogen economy. So thank you very much. My 1 minute, I think, is over.
Yeah, more. Thank you. I would like to ask also the other panelists to say in 1 minute and I will challenge them not only on that. Suppose that you meet Mrs. von der Leyen in the lift with the social distancing, of course, and the mask and everything, right? You have just 30 seconds to give her a message about the European strategy on hydrogen. What would you tell her? And you have 30 seconds, so it's only one sentence. Well, we begin with you. You had the floor, but 30 seconds. Sorry. Please go on, Mr. Sophronis, and then I would like Mr. Kaberger, Mr. Kremer, Mr. MacPhail, and
I'll tell her, please invest in science. That's all I will tell her, especially in Europe. Europeans should lead, I believe, in view of the fact that science is not so well respected here in my country, the United States.
30 seconds. Thank you.
Okay,
Mr.
Thanks, many
Mr.
thanks.
Kremer.
I should say a sentence that is well known even to Miss von der Leyen. So the European target at 2050 won't be reachable without hydrogen. So hydrogen is a key enabler that is looking to meet the targets. And not only the targets on decarbonization, but even on depolluting our cities. Consider that there are more than some hundred thousands deaths by pollution every year in Europe.
Thank you very much. Mr. Kaberger?
Yes, I would like to say first that environmental taxes and costs are indeed important. And when Christian spoke, I agreed on almost everything. But when it comes to trucks, one major truck manufacturer in Sweden commented on Tesla's battery electric truck, saying that it might be good if you wanted to transport potato chips. The other truck manufacturers did a more careful analysis and checking Tesla's performance compared to real experience of their customers as they had logged it. It showed that a great majority of their customers would benefit from a Tesla truck compared to a normal truck. And it does has an implication on environmental taxes, because one reason why European trucks have very large diesel tanks is that they all want to fill them up in the country where taxes are lowest and then drive them around the continent. But battery electric trucks are more competitive than many believe. Thank you.
Thank you very much. Mr. MacPhail?
Well, I would say definitely listen to what Mr. Sophronis said. So support science. That is where our key competitive advantage lies in Europe again, a knowledge economy. I would also, however, warn against some of the easy measures that would like in taxing is a good measure, is a strong measure, but you want to avoid the public reacting like the Gilets jaunes have reacted, and you want to get them on board. So think tax breaks and not taxing.
Thank you very much. Guess what? We still have 3 minutes, so I will give 1 minute to Christian and 1 minute to Juan, and then we're finished. Christian, 1 minute. Although you meet Mrs. von der Leyen.
Yeah, well, never mind. I still have a recommendation to get things moving as fast as possible in the right direction. And it's both helping hydrogen and helping also the commercialization. What we need is auctions, large-scale auctions at gigawatt level of contracts for difference. So to say, I want this amount of hydrogen, and who can produce it at the lowest price? I will support a price of €1.50, let's say, per kilogram. And who can offer me who needs the least money from me to make that feasible at the scale of 1 or 2 gigawatt? That, I think, will be the biggest driver of the hydrogen usability in Europe.
Okay, and I will simply repeat that the science of today is the innovation of tomorrow, and it is the growth and the jobs of the day after tomorrow, which is a little bit the same as the other messages. We are done now. I would like to thank you very much for this very interesting discussion. Personally, I learned a lot. I'm also grateful to the organizer for having given me this chance. I would like to apologize to the panelists if I've been rough in cutting or in asking to reduce the length. It was to have enough time for all the questions. There is one question we didn't take on board on the use of hydrogen in defense. And of course, if you would like to submit this question to the European Commission, this defense program is handled by the way, DG Growth. So I think Christian could channel the question to the right destinataire. Thank you very much again. Wishing you a nice afternoon, and thanks for your attention. Goodbye.
Thank you. Thank you very much.
Thank you. Goodbye.
Thank you.
Have a good day.
Bye-bye.
Thank you to all the speakers for accepting INL invitation and for your invaluable insights. Thank you, Hélène, for moderating so rigorously this session. We do also thank all the attendees of the INL Hydrogen Summit that enriched the discussion in this session with their questions. Much appreciated. We will now have a time for a short e-coffee break. We suggest you may take this short break to visit the networking area and have the chance to meet with other participants and share interests. You can also visit the exhibition and know more about INL. We will back in 15 minutes, 15 minutes. Please come back for the roundtable discussion on innovation for the Europe's hydrogen industry. See you there. Thank you. And we're back. Thank you for being with us. As previously announced, the final moment of this first day of the Hydrogen Summit brings together several specialists to discuss the innovation for Europe's hydrogen industry. We welcome Maria João Duarte from Mitsubishi Heavy Industries and member of the Hydrogen Council, Helena Verdu, senior process technologist and hydrogen expert from Repsol, Patrick Nuben, representing the New Energy Coalition and the Hydrogen Valley in Groningen. We'll also have João Amaral, Chief Technology Officer from Voltalia, and Pedro Ávila, the Strategic Energy Studies and Innovation Director at REN. To moderate this roundtable, we have with us the President of the COST Association, the European Cooperation in Science and Technology, Paulo Ferrão.
Hello. So I hope that you are able to listen to us, and you are all very welcome to this panel on innovation for European hydrogen industry, which of course is in the context of this Hydrogen European Strategy Seminar organized by INL. And as it was mentioned, it is of course very clear that hydrogen is pointed out as a key enabler of the ambition to have a carbon neutral Europe by 2050. And in particular, due to its role on the decarbonization of gaseous fuels. But of course, together with a variety of opportunities, the way forward still brings a lot of challenges and requires R&D to support innovation in processes, in technologies, in infrastructures, as well as, for example, in business models. And this is why today we have this great panel of experts from different areas to bring us important contributions on the innovation that is taking place associated to this hydrogen economy, I would say. So the panel has been presented, and my role here is very easy. So what I would like to do now and up front is to put you one general question that I would ask you, each one of you, to address. And then I have a specific question to each one of you. So my general question is basically that, assuming the European goals for carbon neutrality in 2050, which are the key opportunities and challenges that green hydrogen adoption will represent to your organization? So this is a basic question to all of you, and this will allow the audience to have an idea of how it impacts the different fields. And then I have a specific question to the speakers. So, for example, to Maria João Duarte I would like to ask, what are the main innovations you are anticipating in the industry in order to make use of hydrogen being competitive with other fuels? To Helena Verdu, I would like to ask, what are the main innovations you are anticipating in the energy infrastructures in order to make use of the hydrogen, again, competitive in the context of the other fuels? To João Amaral, I would like to ask, how will hydrogen adoption influence the design of renewable energy technologies? And to Pedro Avila, I would like to ask, what is the role of gas distribution networks as large-scale storage for the energy system in a coupling sector view, with and which innovations are required? So I think we are in conditions to start, and I would like to invite Maria João Duarte to make her intervention.
Hello, good afternoon, everyone. Thank you very much to the INL for inviting the Hydrogen Council, which I am today representing, as well as, of course, Mitsubishi Heavy Industries, a member of the council since 2018. Allow me just to start by introducing briefly the Hydrogen Council, perhaps for those that are not familiar with it. The council was created back in 2017 during the World Energy Forum in Davos by 13 member companies. It's a global CEO level initiative, and it's one of a kind, I would say. As I said, we joined shortly after the launch. Today, the council counts with more than 90 members, which goes to show the excitement, but also the commitment of industry to hydrogen. So this being said, in terms to go to your question, Professor, opportunities. Well, MHI is particularly well positioned across the hydrogen value chain, with several solutions ranging from the production of green hydrogen to the consumption. And just to name a few of those solutions, I will mention our offshore wind turbines. We have recently announced an investment decision in electrolyzers, in an electrolyzer company manufacturing in Europe. On the demand side, we have our solid oxide fuel cells. We have 9 demonstrators in Japan, and the first one in Europe was just announced in Germany. And we have our hydrogen gas turbines. Last and not least, because we think it's quite important in this context of climate neutrality, we have also hydrogen solutions for steel industry. So as MHI, we are, of course, see hydrogen as a big thing in the climate neutrality context. And this brings me to the fact of its versatility and to the fact that when we talk about hydrogen, this was already mentioned during the other panels, at least those that I had the chance to attend, we can at the same time deliver on the climate neutrality aspect while also delivering on growth and competitiveness of Europe and of the industry, allowing not only to create new jobs, but also reskilling those that will no longer be appropriate or adequate in the context of climate neutrality. Finally, on the opportunities, and I think that's the most relevant of all from my perspective, we managed to avoid stranded assets, which is a major concern in terms of financial stability. And I talk about global financial stability. I think we all know that investments made today or along this decade will most likely be around in 2050. So we have to really look at these very carefully. Because I'm an optimist, in terms of challenges, I will name just 2. It is it will be interesting to understand how we will orchestrate the complex and international supply chain for hydrogen, for green hydrogen, and how we will scale up, bring the megawatts to the gigawatt level, bring the renewable electricity volumes we will need. And I will end here and leave the floor to my other colleagues. Thank you.
Thank you very much, Maria João. So I would now like to invite Helena Verdu.
Okay, hello everyone. Thank you very much for inviting me to this session. I'm very glad to participate in this roundtable with the rest of my colleagues here today. And first of all, we can come with your first question around the opportunities and the challenges that green hydrogen adoption could represent for, in my case, Repsol. Well, as you may know, hydrogen is a key element for Repsol, for my company. First, we have been using hydrogen for decades in our refineries to reduce the sulfur content of our fuels, contributing to the reduction of sulfur oxide emissions. In fact, we are currently the biggest hydrogen producer and consumer in Spain. This hydrogen, as you can imagine today, currently, is produced using the conventional steam reforming processes and using natural gas as a feedstock. And the emission of CO2 related with that process are almost 20% of the direct emission of our refineries. So as a company committed with the decarbonization, we believe that we have to both promote hydrogen technologies capable of significantly reducing these CO2 emissions, and at the same time not losing sight of other technologies which can accelerate the deployment of these hydrogen applications. Currently, one of the projects that we are developing in order to use this renewable hydrogen and to develop this kind of technologies, for example, in that case, the electrolysis one, is the production of synthetic fuels, e-fuels, using renewable hydrogen as a feedstock together with CO2 in our near our Bilbao refinery, in order to produce these synthetic fuels that are net zero emission fuels. But we also are seeing an opportunity in the use of biomethane, for example, for the production of hydrogen through the conventional process, but changing the feedstock. This biomethane could be obtained from biological waste or from biomass. And the benefits that we see here is that these hydrogen production routes allow us to use our existing installations. Finally, we also don't rule out producing hydrogen through the conventional steam reforming processes, but applying a CO2 capture. With this CO2, we can use the CO2 to produce other high-value products, as e-fuels or e-chemicals. But on the other hand, there are new applications for hydrogen that we have seen today that can help decarbonize other Repsol businesses, not only the industrial one, such as, for example, mobility with the fuel cell vehicles in road transport, or via synthetic fuels, I mentioned it before, for maritime or aviation transport. And for example, to provide flexibility to the power system as the share of renewable energy in power generation increases. So at Repsol, we see hydrogen as one of the ways to achieve our goal of decarbonization. The problems and the challenges we are facing now are obviously that these processes are not yet competitive, and the need to build a regulations and a standard around all these new uses of hydrogen. And in order to achieve a robust hydrogen economy, it is necessary to focus on all the different parts of the hydrogen value chain, from renewable power generation to production and end-use application. Obviously, through the entire process, the support of public institution and collaboration between all the sector involved is key and critical.
Thank you very much for many good ideas that we will need to come back in a second round. And I will like now to invite João Amaral to make his contribution.
Good afternoon, everyone. And naturally, thanks for the invitation. It's a pleasure for Voltalia to be represented here. Again, many thanks. Looking a little bit to today's context, we would tend to say that the main opportunities would be decarbonization. It would be a new word that I've just come up, I would call it, and it's today's word, decovidization, okay? And also demystification. And let me go into detail to each one of these three words. So decarbonization, I don't think it needs a lot of details on what it means, why we really need it, but it's definitely one of the core reasons why all the fuzz, all the trendy words, all the news in the media about hydrogen. It's one of the main reasons. So decarbonization, I think it's quite well explained. It's not only an opportunity, but it's also the challenge that we need to go for. Decovidization is a challenge of today. So we will need to push investments. The economy will need some further investments. So this also creates an opportunity that will make all the companies think on what to invest for. And demystification, we tend to talk about many of the incorrect informations or scenarios that are posed when people tend to speak about hydrogen. And that usually leads to common mistakes. Those common mistakes are the lack of understanding on long-term targets that should be set if we talk, as you were posing in the question, to 2050, or eventually if we're talking to 2030. Those targets will be different, but they need to be rationalized today. So we also believe that there will be a race between non-hydrogen and other technologies that will compete in some aspects. I tend to usually say or use the example that you can go to the car dealership today and buy easily an electric car in Europe, but it's much more difficult to buy a hydrogen car. So that's one of the challenges, and it's a race that we see. We also see it because currently it's available in the industry, some skills and technologies that could help the hydrogen economy, but they could also be fighting against this hydrogen possibility of development. So we really need an energy transition. I think that's the main point of the opportunity that we would see. And naturally, we'll have still some time to go into some further details.
Thank you very much, João Amaral. So I would now like to invite Pedro Ávila to have his comments.
Okay. Thank you very much, first of all, to INL, to this invitation. INL, nowadays, we are at the beginning of a partnership to increase our innovation ecosystem, and also to Professor Paulo Ferrão to this invitation. Just a few words to start. I think nowadays we have a new scenario that is a wide approach of energy system. In the past, we hear this, but it's just in the paper. I think nowadays we believe on this. We start to talk about the sector coupling and the evolution of these words to smart sector integration. What is this? Is that in the past, all of the system, electricity and the gas, are two pillars that didn't talk about and didn't see other synergies of them. In the European level, we have some development plans, TINDP, that is forecast to 10 years, and all of these TSOs design their plans alone. Nowadays, they are integrated these plans. So to increase the electrification in all of the economy, it's very important to have a huge storage capacity. So the gas has a key role to play nowadays on that, because when we increase more and more the percentage of electrification, the key is to use the assets that my colleague said, Maria João, to use these assets to put on the economy and to use the surplus of the energy supply side in gas. And I think I will more deeply in the second question that has Paulo already mentioned, to explain how RAN envisages this issue.
Okay, thank you very much. So, well, let's focus on some of the aspects that you have mentioned, and it was very clear that when we speak about hydrogen, we are in fact speaking about different things, and the hydrogen is the same, but of course hydrogen is an energy vector, and an energy vector is transforming something in something else. So, and I think Elena made a very good point. So my question now to you is, where are we going to get the hydrogen from, and what will we do to the hydrogen? Of course, there are already presented many different things. So many of you have, I understand, consider that it could, of course, come from electrolysis. So, and this means for sure renewable energies and transforming the renewable energies. But of course, it was also mentioned biomethane, for example, from, well, biodigestion of municipal solid wastes. And then we produce the hydrogen, and we could then transform the hydrogen in immediately making use of the hydrogen. For example, RAN has fantastic projects and ideas to have the hydrogen injected in the national grid. And then basically we are, there are, I think Pedro in the second round, I will ask him what are the challenges, there are many, on making use of this injection, and what are the type of innovations that we will need for doing this. But also, we could produce, for example, those synthetic fuels. And I'm always very much interested in this idea that Elena has also put forward, which is to make use of the hydrogen to combine with CO2 from the flue gases of many different industries, and to do what we call the methanization, and then produce synthetic fuels. And then my next question to all of you is, what would you see come first? So are we, because of course the challenge is for the user, now not speaking about the hydrogen, but about the user. So we have our cars, So they run on gasoline or diesel or whatever. So are they going to run on synthetic fuels? Are they going to run on hydrogen directly? Are they going to be electric? And then are we at our homes going to consume hydrogen through the mixture in the natural gas? So because of course the challenges are so different and the type of investments are so different, the innovations required are so different, so that I would like to invite you to have your guess. So where do you guess this will start to happen first? And which are the innovations that, well, based on the perspective of your organizations, are now required to transform your operation in order to make this feasible? So eventually we will go around again. Maria João.
Thank you very much, Professor. So you asked a couple of questions all in one. I'll try to address them both and in a concise manner. Hydrogen, where does it come from? We talked about electrolyzers mainly, and I think that's the end game for all. But that really depends mostly, or at least for us, it depends mostly on it's a regional feature more than anything else.
Maria João,
yes.
May I challenge you with the following? Pedro Avila mentioned very explicitly that, of course, and I agree with him, the easiest and the fastest way to use these in an economical way is to have the excess of renewable energy produced by the current assets that are already in the position there, and to produce hydrogen instead of, for example, stalling the wind turbines during the night. I don't know, things like this. But do you see opportunities of business models for well, making use of dedicated power systems, renewable energy power systems to the hydrogen? Is this different? Does it promote new challenges? So, as you were speaking about that.
So I think it's an incredible, hydrogen represents an incredible storage medium in that way, and it allows for a certain level of arbitration, if we want, and in the electricity market. And in a certain way, it is for many perhaps also a way, or for investors in renewable energy projects, also a way to hedge that market, those investments. Definitely, that will be a primarily, and it is a primarily way to see or to approach hydrogen. I think that we will see also as first applications industrial uses, but it really depends also on the grids we have, on the assets we have. Something we never talk about is hydrogen use in power generation. We can talk about efficiencies and we can argue over that. But the reality is that the assets are there, they're running on natural gas. Climate neutrality will not be delivered on those gases, on fossil gases. And what do we do with those plants in 2050? And what do we do with the system? So that is also a possibility. And we have over Europe a quite well-connected grid, electricity grid, which allows us to stabilize, and hydrogen will be a storage medium, but it's not everywhere the same. We have a lot of islands, we have a lot of geographical limitations as well in some grids, in Italy, Ireland. So it's really a big puzzle, and we really have to get all these elements together. So it's not a question of convictions, it's just a question of what is cost effective, and that delivers on these climate goals. I hope I answered the question.
Oh yes, for sure. This has very good contribution. Elena, would you like to come up with contributions to this round?
Yes, of course. Thank you. For what we see before. It's a difficult question to answer, but we see more probable a centralized production or generation of hydrogen near the industrial clusters because of the fact that what was mentioned before, that the production cost of this way of production of the hydrogen is less costly that small that thinking in small electrolyzers, decentralized for all the for the different areas, and from that we visualize the deployment of the different application and uses of this hydrogen. For example, for mobility, for the heavy road transport, for city buses nearby, and for this type of things, and also promoting the synthetic fuels and the e-fuels. But for this type of e-fuels, we think that we will have to wait a bit more, because first of all we need the renewable hydrogen, of course, and after that, well, when we reach the competitiveness of the different pathways to produce hydrogen, then we visualize the expansion of the rest of the applications through the entire value chains. But having said that, almost besides we visualize these centralized productions in the industrial clusters. I have to say that the industry, and it's the focus on this of this round table, have a lot of challenges to reach, because we cannot forget that industry that currently use hydrogen use this hydrogen in a mode of 24 hours per day and 7 days per week. And that's why Repsol is developing different ways to produce this hydrogen, because we consume the same hydrogen per day and per night. And we had to be sure that we are going to have the availability of this renewable hydrogen, this low carbon hydrogen, to be able to decarbonize our processes.
Helena, I have a very specific question to you. Mm-hmm. So do you know about any investment planned or from Repsol to manufacture such a plant of using hydrogen to capture the CO2 and produce synthetic fuels?
Yes. For this is this project is based in the north of Spain, in our Bilbao refinery. For us, it's a demonstration project for be able to check the production, or the right way to production these synthetic fuels. We will use renewable hydrogen from an electrolyzer together with CO2 that is already captured from our refinery, in order to produce these e-fuels. The capacity will be around 50 barrels per day, and the startup is planning for the beginning of 2024.
That's very interesting. Yes, thank you. If we have time, I will come back with a question on general question, but also on that. But of course, now I would like to pass the word to João Amaral. Thank you, William, very much.
Well, Paulo, following up what the panel colleagues have been saying, we still see we are an IPP, so we are mostly active in the renewable sector, as you might know. We see electrification as being key today and tomorrow. So we believe that hydrogen will be the complement needed for this growth in electrification, and maybe not as much as the other way around sometimes is transmitted. So transport of hydrogen, when we already have quite good electrical grids as the one from REN, even though they will have challenges when all the solar power will be connected to the grid until 2024 or 2025. We are talking about, from what we can read, over 7 gigawatts of PV, plus what will be installed in self-consumption. That will pose a significant challenge. Thus, we believe that curtailment may become the new reality on PV and eventually on the coming wind. So all of that will be very difficult to balance without an appropriate storage capacity, being that a conversion to gas, okay, we can also see the same, but definitely the challenge will be in the full load equivalent hours that we are used to see in the renewable sector, but applying that to the electrolyzers. So how many hours will, in fact, that large investment in electrolyzers, how many equivalent hours will that be applicable to each of those investments? And that's the hard part to explain the €1 billion of expected investment that are announced. Portugal around 7 billion, France more or less the same, Spain more or less the same. So each country is talking about more or less the same volume of investment, and it becomes quite difficult to understand at the first perspective on those figures exactly how can it work if an electrolyzer is just capturing excess renewables, and those renewables will be working at equivalent hours, 4,000 hours, a very good wind farm, or 2,000 and a few hours for very well designed PV plant. So that design capability, the capability to design renewables that are able to be combined with hydrogen, it will be definitely a challenge. And for that, we believe that technology is key. We believe that the industry will invest upon the right stimulus. That's why all the discussion about stimulus packages to invest in hydrogen, and we usually at Voltalia, we don't focus only on hydrogen, we focus also on other molecules for the power density that those can bring. But it's important to create bonds between those vital political decisions and basically the daily lives of citizens and companies.
Thank you, João, for those very good points. But of course, and I agree with all what you have said, but certainly if we want to decarbonize the gas, hydrogen has a unique role. So I fully agree that we are not going to substitute electricity by hydrogen directly. It makes little sense, but eventually it makes much more sense to decarbonize the gas. But so my question is, REN ready to support the country in being the storage company for the hydrogen that is going to be produced, and how far will it be viable soon, Pedro Ávila?
Okay, we are working very hard on this topic, and I'll try to put my explanation with a high level to a low level question. So REN is an enabler for the implementation of this strategy that is not a local strategy, but it's a European level strategy. So an integration for both systems, electricity and gas, for my perspective, is key to the perspective of coordinating planning, security of supply, management of the electricity and gas system, and regulatory framework. This is very, very important to have these four pillars very, very, very accurate in all of the documents. Currently, there are more than 1.5 million customers and more or less 2,000 kilometers of both transmission and distribution network. It's a lot, so it's constitute a relevant asset for the economic viability of the process and to allow for scale up, thus enabling the progressive decarbonization of wide range of consumptions. At the REN gas transmission side, the underground storage operated by REN Armazenagem with a storage capacity of 300 more or less mega cubic meter and 1,040 kilometers of high pressure, which is operated by REN gasoductos, are a natural storage solution for the H2 and the natural gas blending. So using this infrastructure will provide secure and reliable long-term storage, considering that gas storage facilities already allow greater flexibility of the overall energy system and can make hydrogen available for the system and for the consumers. For instance, just to do an example, if we consider 6.5% of hydrogen at volume blending at the REN system, it can store more or less 80 gigawatt hour. It's huge capacity energy. So hydrogen offers huge potential to decarbonize the energy systems for giving synergies between economic sectors and energy carriers, as well as storage potential for renewable electricity, and use the existing infrastructure to transport gas blends. Another point that is very important also contributes to this risking of some electrolyzers big projects, allowing for the introduction of surplus H2 when the base load of industrial process doesn't need this energy. It's very important because it's natural to put this on the network. So what is the point? But nowadays we have significant challenges to address before hydrogen injection, and I'll try to address some of them. One of them is to increase smart gas grid concept combined with the digitalizing of process. It is therefore crucial in order to guarantee the feasibility of the introduction of hydrogen in different areas of network according to feasible limits of variation and mixing appropriate to the adaptive response of users. Another one is the gas quality control and aspects of interoperability in the European network, in particular to the Spanish network. Another one is the implementation of new system management procedures and IT developments for quality monitoring, and give the information for the end users, especially the big customers, and to have the quantity of the energy that are delivering at each supply point, so to proper energy billing. Another one is the introduction of new approaches in the existing monitoring and maintenance routines to guarantee reliability, safety, and lifetime of the assets. And last but not the least, planning the definition of injection points and permissible levels of hydrogen in natural gas infrastructure. It's essential to ensure decarbonizing into a coordinated manner. On the other hand, it's similar to electricity side. The reserve of capacity should not obey merely economic criteria or geographical convenience of renewable electric generation solutions. The effect of the introduction of hydrogen into the infrastructure, in addition to condition downstream the maximum hydrogen concentration level. So it's a lot of issues we have to address and combine these two rigorous assessments to check the fit for purpose of existing steel pipeline, natural gas, and the underground storage to have sure this compatible for the introduction of hydrogen. But we believe on that. We are doing very hard work to put this in practice in the next years.
Thank you very much for this very comprehensive analysis, Pedro. And now I think we have some questions from the attendees. So it's time now to respond to those questions. I think in a certain way they have been addressed, but we have a question which says, what is still needed for hydrogen to be interesting for industrial use? And another question say, well, today it's almost impossible to imagine a future without fossil fuels due to their relatively low cost and availability. And so considering this, is hydrogen really an alternative right now? Well, I think, well, I'm not here to respond, so I leave this to you. So any one of you would like to provide some answers to these questions?
So I would take up the first question, definitely. What is still needed for hydrogen to be interesting for industrial use? I think as other colleagues in this panel mentioned, Elena in particular, hydrogen is already being used in industrial processes. What we need to make renewable hydrogen or other forms of low carbon hydrogen attractive for industrial uses is really more on the, so there are of course the technical aspects of bringing technologies from their infancy in terms of pilots to industrial scales. We are working on that. But I would say that mostly it's a question of bringing price parity with fossil fuels. And for that, we need regulatory solutions. The difficulty here perhaps is that unlike solar and wind, green hydrogen, production is driven by operational and not capital expenditure, with 80% of the cost depending on electricity prices. And so if we can really give incentives to bring the costs down for electrolyzers, for instance, but we still have to deal with the electricity part. I think one of the solutions that is being discussed at European level and that we pretty much think is a good solution, if well designed, of course, are the carbon contracts for difference for decarbonization projects. And I think those tools will be needed to bring really this demand from the industrial users. I would say that I will leave the mobility question for another call.
João, I was going to ask you this question if we had time, so now I have another opportunity. So you You have mentioned regulatory stimulus. Can you elaborate a little bit on that? So which are the regulatory stimulus that you are alluding to that we need?
Thank you, Professor. So I think we have, of course, the carbon price. We have today the EU ETS. The carbon price has already started delivering on fuel switch, for instance, from coal to gas, but definitely is not delivering on gas to renewable or decarbonized gases. And so we perhaps need additional mechanisms. We need to reinforce the EU ETS, for instance, but we need also additional mechanisms. And one of those mechanisms perhaps is this carbon contract for difference idea, where we have the carbon price, but we also set another number, and that gap is covered. Therefore, I think that is one of the options. What we also need, and this linking to synthetic fuels, where we are also very active in, and the fact that hydrogen might as well become a commodity, either directly or in the form of ammonia, methanol, which are already traded internationally. It's a question of certification schemes. We will need that, and we will need that at European level, but we will need that internationally as well. So that will also be necessary to make sure that we have the level playing field industry needs to remain competitive. And
wonderful.
Yes.
I thought that was really useful. Thank you very much. So while you think if you have any other comments, so there is another question from the audience, so which says, how would you describe the current collaboration between industry and the scientific research organization regarding the exploration of hydrogen? And what I will do now is I will give an opportunity to all of you, if you want, to come back to say a few words about this or any final word that you might have, because we need to close in the next 5 minutes. So I will give, would say 1 or 2 minutes to each one of you. And please go ahead.
Okay, perhaps I can answer the question from the public related with the collaboration between the industry and the scientific researchers organizations. I have to say that today more than ever is essential this close collaboration between both parts. The industry need these research organizations for a correct develop of the technologies we need for this huge goal that we have through the way of decarbonization that we have to reach. And for us, we have one example in Repsol. We are developing a new technology for green hydrogen productions based on photoelectrocatalysis, and we are developing this project with Enagas, but we are collaborating with several other research organization, very important for us from Spain, that are the ones that are leading this work with us, and for us are a very important piece of this developing of this project that we have now in our hands.
Thank you very much. Pedro or João, would you like to have some further saying on these topics?
Just to say the first of that, for regulatory framework, the green gas certificates, it's fundamental for market integration and the efficiency of that. And the other question, I agree, it is very important to work closely to the academic institutions. And we see it very well in our innovation ecosystems, that working together we can plus more, and we have more results to involve the Portuguese enterprises and moving for the hydrogen, because there are a lot of knowledge on that. So we have problems. There are knowledge in the academic side. We will join this and bring together with this project.
Thank you so much, Pedro. João, do you have any final?
Yeah, maybe a last comment on the question around mobility, because the person in the audience has mentioned that it's the relative low cost on the fossil fuels that eventually prevents the change to hydrogen or any other technology. Well, I would agree that the fossil fuels are relatively low cost, but with a huge parcel of taxes. And it is those parcels of taxes that already exist that they need to be worked out, as Maria João was saying, Pedro or Elena, to bring hydrogen to the next level, and especially to have consistent targets that we, from the developers, that we start developing projects, can really adapt what we do on a daily basis to make the projects happen, and not only from our perspective, but from the full value chain that we are connected to, and that's the energy and electricity value chain.
Wonderful. So I think what I should absolutely do is to thank the four fantastic speakers, so which brought us very, very important issues on the need for innovation in hydrogen, and also for what is happening now and what needs to happen in the near future. I would, of course, also like to thank to INL for having organized this seminar. And I thought it was a very nice session with a lot of great ideas on how to put the hydrogen, well, in the next level, as you have mentioned. So thank you very, very much to all of you. Thank you to INL. Thank you for the attention of everyone which was attending the session. And back over to the control at INL. Thanks a lot and have a good afternoon.
Thank you to all the speakers and also to the attendees of the first day. Tomorrow at 9:30 GMT, we will be back for a full morning of discussion and insights at the INL Hydrogen Summit. We are waiting for you. Thank you and see you tomorrow.
Thank you very much.
Bye-bye. Nice to meet you.
Thank you.
Thank you. Bye. Thank you very much.